Hi everyone. Thank you for taking the time to participate in this meetup. Today, I will bring you the topic of insight into Apache ShardingSphere. Firstly, please allow me to introduce myself. My name is Duan Zhenqiang. I'm currently working as a senior Java engineer at Sphere EX. And a committer of Apache ShardingSphere. I love open source very much, and I'm focusing on the development of Apache ShardingSphere database middleware. Okay, today's topic is divided into 4 parts. In the first part, I will briefly introduce the Apache ShardingSphere project. Secondly, I will introduce the architecture of Apache ShardingSphere and the usage scenarios. In the third part, I will focus on the core features of Apache ShardingSphere, including data sharding, read-write splitting, distributed transaction, database governance. In the last part, I will introduce the active open source community of Apache ShardingSphere. Let's get straight down to the part 1. You may wonder, what is Apache ShardingSphere? Apache ShardingSphere is the top-level Apache project and the first distributed database middleware of Apache Software Foundation. Now, the project has more than 200 community contributors and hundreds of practical cases in various industries. Apache ShardingSphere is an open source ecosystem consisted of a set of distributed database solutions, including 3 independent products, JDBC, Proxy, and Planning Sidecar. They all provide functions of data sharding, distributed transaction, and data governance. Now, it has supported MySQL, PostgreSQL, Oracle, SQL Server, and any SQL 9.2 followed databases. Apache ShardingSphere aiming at making full use of the computation and storage capacity of existing database in distributed system and focusing on providing increment functions. In the third part, let's take a look at the architecture and usage scenarios of the 2 core products of Apache ShardingSphere, ShardingSphere JDBC and ShardingSphere Proxy. ShardingSphere JDBC defines itself as a lightweight Java framework that provides extra service at Java JDBC layer. It can be considered as an enhanced JDBC driver. Users can integrate ShardingSphere JDBC like native JDBC. Another project, ShardingSphere Proxy, defines itself as a transparent database proxy, which is completely transparent to applications and can be used directly as MySQL or PostgreSQL. The following table is a comparison of 2 products, ShardingSphere JDBC adopts decentralized architecture applicable to high-performance, lightweight OLTP application developed with Java. ShardingSphere proxy provides static entry and all language support applicable for OLAP application and the sharding databases management and operation situation. Based on the different characteristics of two products, it is a good choice to use a hybrid architecture to mix the two products. By using the same registry to unify sharding strategy, Apache ShardingSphere can build an application system applicable to all kinds of scenarios. In the third part, I will focus on the core features of Apache ShardingSphere, including data sharding, distributed transactions, database governance, and new developed features in the version 5. As is known to all, the traditional solution that stores all the data in one concentrated node has hardly satisfied the requirement of massive internet data scenario in three aspects: performance, availability, and operation cost. In order to solve the problems, the data sharding solution came into being. Sharding refers to splitting the data in one database and storing them in multiple tables and databases according to some certain standard, so that the performance and availability can be improved. Sharding method can be divided into vertical sharding and horizontal sharding. According to business sharding method, it is called vertical sharding. The core concept of which is to specialize databases for different uses. Tables are categorized into different databases according to business, and the pressure is also separated into different databases. The following figure shows the splitting of DB into DB0, DB1, DB2 according to business needs. Vertical sharding usually requires adjustments to the business architecture. This method can ease problems brought by the high data amount and concurrency amount, but it also requires horizontal sharding to solve the problem completely. Horizontal sharding categorizes data to multiple databases or tables according to some certain rules through certain fields, with each sharding containing only part of the data. For example, according to the ID field of the user table to take sharding with mode algorithm, the event ID is put into DB0 and the order ID is put into DB1. Theoretically, horizontal sharding has overcome the limitation of data processing volume in single machine and can be extended relatively freely. So it can be taken as a standard solution to data sharding. There are cases in the Internet industry where there are a large number of concurrent read operations and fewer write operations at the same time. In order to deal with these cases, the database is usually split into a primary database and a replica database, usually called read-write splitting. The primary database is responsible for the addition, deletion, and modification, while the replica database is responsible for queries. It can significantly improve the query performance of the whole system. While data sharding and read-write splitting improve performance, they also brings new challenges to developer, operation, and maintainers personnel, and their work will become more complicated. Facing these challenges, Apache ShardingSphere not only provides data sharding and read-write splitting functions, it also hides the related impacts and allow users to use the entry database cluster like a single database. As shown in the figure below, we have configured data sharding rulers, including two databases, DB0 and DB1, and each database contains two tables, T-order 0 and T-order 1. When we use data sharding in our application, we exclude circle through the logic table T-order. Apache ShardingSphere rewrites the logical table T-order into the actual table DS0 T-order 0 according to the sharding algorithm. At the same time, in order to meet the requirement of different scenarios, Apache ShardingSphere has built-in multiply sharding algorithms such as hash, range, and time. For special requirements, users can implement the sharding algorithm by themselves. In complex sharding rulers with more data nodes, a large number of configuration repetitions make configurations difficult to maintain. Inline expressions can simplify data node configuration work. And after data sharding, different data nodes need to generate a globally unique primary key. Apache ShardingSphere currently provides built-in distributed ID generators, such as UID and Snowflake, and also extracts the interface of the distributed key generator for users to implement. State sharding will lead to distributed transaction problems. Apache ShardingSphere provides users with a unified distributed transaction interface and integrates existing mature transaction solutions. To solve the problem of distributed transactions, we recommend using a reasonable data sharding method to convert distributed transactions to local transactions, which can effectively avoid the trouble caused by distributed transactions. When cross-database transactions cannot be avoided, some businesses still need to keep transactions consistent. Apache ShardingSphere supports XA transactions and base transactions by default. Users need to balance performance and functionality due to different applicable scenarios. From the table below, we can see that the performance of XA transactions is severely degraded and cannot meet the requirements of Internet high concurrency scenarios. Base transactions have better performance, but corresponding business transformations are required, and the cost is very high. In addition, ShardingSphere also provides complete database management functions, such as dynamic configuration, highly available circuit breaker authority, circle audit, and APM. For more information, you can refer to the official ShardingSphere document. Now, Apache ShardingSphere is in the rapid development of version 5. The latest version provides new features such as dist circle and scaling. Dist circle is Apache ShardingSphere specific circle. The goal is to break the boundary between middleware and the database. It allows developments to use Apache ShardingSphere like a database. Dist circle can be divided into RDL, RQL, and SCTL. As shown in the figure below, we can use circle-style RDL statements to add data sources and sharding rulers easily. Data scaling is a general data migration and data scaling solution provided by Apache ShardingSphere. The goal of sharding scaling is providing a common Apache ShardingSphere scaling solution, which can support kinds of sharding strategies and reduce the impact as much as possible during scaling. Currently, it is in alpha development. Last but not least, Apache ShardingSphere has an active open source community. At present, the project has more than 200 community contributors, has gained nearly 40,000 stars on GitHub, and has acquired more than 160 production users, covering multi-industry, covering multiple industries such as the internet, financial, O2O, logistics, and cloud computing. Everyone is very welcome to participate in Apache ShardingSphere project and work together to improve these open source distributed database ecosystems. If you want to learn more about the project or join the community, you can subscribe the official mailing list or scan the code on WeChat to join the official exchange group. Finally, thank you again for taking the time to participate in this topic. Thank you.